Hello and welcome to the course of Computer Network. This lecture is in the continuation of our last lecture in which we started designing our reliable data transfer protocol, and we have already designed our RDT 2.0 version of reliable data transfer. But before going into the detail of our next protocol, which is RDT 2.1, we need to understand the flaws and errors present in RDT 2.0. So let's have a look at that particular protocol once again, problems of that particular protocol, and then we will start discussing about our next protocol, reliable data transfer protocol, RDT 2.1. So here it is. These are the flaw present in RDT 2.0. If your acknowledgement or negative acknowledgement, which is coming from the receiver side, gets corrupted, then what will sender do? And as we can see, if ACK or negative ACK uh, received by the sending side is corrupted, then anyhow sender has to retransmit that particular packet to the sending side. But it's a problem with the receiving side, because at the receiving side, how will receiver will get to know that the packet which it is receiving now is a fresh packet or a retransmitted packet? It would be a fresh packet for the receiving side if last received packet was corrupted, and it will be a retransmitted for receiving side if the last received packet was fine, but the acknowledgement of that particular packet got corrupted in a way going to its sending side. So this is the main problem of this particular protocol, which is also called a stop and wait protocol, because in this particular protocol, sender sends the data and then waits for the acknowledgement. Without the acknowledgement of the last sent packet, sending side will never send the next packet to the receiving side. So this happened in RDT 2.0 version of our reliable data transfer protocols, and now in the next version of RDT 2.0 we have to remove this problem of getting confused in retransmitted packet and a fresh packet. So here we can see this RDT 2.1 protocol, which includes, these are the two things, these are the two sequence numbers, 0 and 1. With the help of these two sequence numbers, uh, RDT 2.1 will remove this fatal flaw. So here you can see in RDT 2.1 sending side, this is the sending side of RDT 2.1, and this time you will find 4 states in this particular sending side because of the two sequence numbers uh, involved with the sending side. So now whatever data is sent by the sending side has a sequence number. So we'll start with this particular state. Wait for call 0 from above. You can see over here that data comes down to the transport layer, and transport layer uses a reliable protocol for sending this particular data after making a segment. For making segment, this RDT 2.1 uses checksum along with the sequence number. Okay, and how sequence number will be helpful to remove that fatal flaw of RDT 2.0, that we will see shortly. So let's understand this particular RDT 2.1 with sequence number. So we are currently in this state. You create a segment with a sequence number and you send that particular segment to the receiver, and you change your state from waiting for call 0 from above to waiting for acknowledgement or negative acknowledgement of packet number or segment number 0 from the receiving side. And here in this particular state you have two possibilities. If the data or packet received by the sending side from the uh, receiving side is corrupted or negative acknowledgement, in both the cases sending side has to retransmit segment number 0, which it has already sent once, and this particular state has to wait for the acknowledgement of packet sequence number 0 again. You can see this loop over here. Again it's waiting for acknowledgement of sequence segment number 0. The second possibility at this state is if the packet received is not corrupted and that particular packet is a acknowledgement. The packet received by sending side is not corrupted and it's an acknowledgement, then this particular state will change its state to wait for call 1 from above. This time it will do nothing, just change the state from wait for acknowledgement or negative acknowledgement of segment number 0 to wait for call 1 from above. Now this time this sending side is waiting for the data from the application layer with um, and transport layer will provide the sequence number 1 this time. So at this particular state, what you are doing, you are creating a segment with sequence number 1 this time, and you are sending that segment to the receiving side, and you are changing your state from wait for call 1 from above to wait for acknowledgement or negative acknowledgement of segment number 1. So here again two possibilities are there. Either the packet received by the receiving side is uh, corrupted or a negative acknowledgement as we saw over here, then sending side will do nothing, it will retransmit that packet again, the second, and it will remain in a same state, because till the time it doesn't receive acknowledgement of segment number 1, it will not change its state to this state. The second possibility is packet received from the receiving side to the sending side is not corrupted and it is a acknowledgement this time. Then this particular sender has to change its state from wait for acknowledgement for sequence number 1 to wait for call 0 from above, because this time the sequence number is changed again. So that is how this sending side works with the sequence numbers 0 and 1. Now this is the receiving side which you see of RDT 2.1. Here you will find two states: wait for 0 from below, wait for 1 from below, because this time two sequence numbers are used for the packets 0 and 1. So let's understand this receiving side. So we'll start with this particular state. This particular state is saying that it's waiting for segment number 0 from the sending side or from the network layer, which is just uh, below this particular transport layer. So once this particular state receives a packet from the sending side, this particular state has three possibilities. The first possibility is this one, which is simple and perfect. Uh, Packet received by the sending side is not corrupted, you can see over here, and has a sequence number 0, which this state is waiting for. Then it will extract the data from the packet and deliver that data to the application layer, and it will create a packet which is known as acknowledgement along with the checksum this time, and send it to the sending side. So it's a idle condition. The second possibility is the packet received by the receiving side is corrupted. Then it has to design a packet which is a negative acknowledgement along with the checksum, and send it to the sending side. And that means it is asking for the retransmission of the packet, and it will remain in this state this time, because till the time it doesn't receive segment number 0, it will not flip its state as this state did in this possibility. When it happened, it changed its state for wait for 0 from below to wait for 1 from below. When segment number 0 is correctly received by this particular state, then it will send a positive acknowledgement along with the checksum, and it will flip its state to wait for segment number 1 from below. But here in this possibility, that required segment is not received by the receiving side, so that's why it's remain in the same state, and it is waiting for a segment number 0 in a perfect way, because the last received packet was corrupted. Now the third possibility, and very interesting possibility, is received packet is not corrupted and has a sequence number 1. Getting my point? You need to concentrate over here, that if the received packet is not corrupted but has a sequence number 1, and it is waiting for packet number 0. So we need to assume the scenario why sending side has sent a sequence number 1 to the receiving side again. So the logic behind this particular possibility is that the last correctly received packet or segment which has sequence number 1 by the receiving side is good enough, and once this particular receiving side send the acknowledgement of perfectly received segment number 1 to the sending side, that acknowledgement got corrupted in a way, and when that acknowledgement got corrupted in a way to sending side, uh, that particular sending side has sent that has retransmitted that particular packet again. I should say read this case retransmitted that packet again, and that retransmitted packet is got sequence number 1, which means this particular packet is already received by this receiver, but due to the problem with the acknowledgement sent by this receiving side to the sending side has to retransmit this particular packet again. And now you will see, for the wrong packet received by the receiving side, what we are going to do, we are creating an acknowledgement for this particular packet along with the checksum and sending to the sending side. This packet is not corrupted but has a sequence number 1, but still we are sending the acknowledgement. Why? Because if we send a negative acknowledgement to the sending side for this particular sequence number, sending side will again send this packet again to the receiving side, because negative acknowledgement says that the last received packet is corrupted. You need to retransmit that particular packet again. So let me brief you this scenario once again in a very simple way, that when your receiving side is waiting for packet number or segment number 0, and your receiving side received sequence number 1, which is the last correctly received packet by the receiving side, then receiving side will send a acknowledgement for that particular packet again, because the last acknowledgement which this receiving side sent for the correctly received packet at the sending side got corrupted. So this particular receiving side has to send acknowledgement for this already received segment with sequence number 1. So with the help of these two sequence numbers 0 and 1, receiver will get to know about the uh, last correctly received packet, and it will not receive the redundant and retransmitted packet from the sending side again. And this problem is removed from this reliable data transfer 2.1 version, because uh, because of these sequence numbers, we have completely removed that problem of receiving a redundant and retransmitted packet from the sending side. Let's again understand this process of receiving side with the help of sequence number 1. It will be just a recap of this state, because let's understand this particular state once again, which is same as this state, but this time receiving side is waiting for segment number 1 again. There are three possibilities that the receiving side receives a packet which is corrupted. So then what it will do, it will make a negative acknowledgement along with the checksum and send that negative acknowledgement to the sending side, and it will ask for the retransmission of the packet, because the packet it received is corrupted, and it will remain in the same state because uh, correct uh, segment number 1 is not received yet. Now the second possibility at this particular state is a packet received by this particular state is not corrupted and has sequence number 0. Getting my point? Has sequence number 0, but it is waiting for sequence number 1. So why sending side has sent sequence number 0 segment again? Only because the sending side has received a corrupted acknowledgement of last correctly received segment of sequence number 0. That is why it has sent sequence segment number 0 again, because that last received packet is was received by the receiver in a proper way, but the acknowledgement sent by the receiving side for this particular sequence number got corrupted in a way. That is why sending side has sent this sequence number again to the receiving side. But in this particular case, receiving side has to send the acknowledgement again for the different packet. or last correctly or perfectly received packet of sequence number 0 to the sending side. So that's why we are sending the acknowledgement to the sending side for this sequence number. And once this acknowledgement is received by the sending side will get to know that this particular packet is sequence number 0. This particular segment is received properly at the receiving side. Now I have to send the next sequence number, which is 1. And after that, if the received packet is not corrupted and has sequence number 1, which is expected by this particular state, then this particular state will extract the packet and deliver the data to the application layer, and it will create a acknowledgement along with the checksum, and it will send this particular acknowledgement to the sending side for the correctly received segment of sequence number 1, and it will flip its state from wait for 1 from below to wait for 0 from below, because segment number 1 is correctly received by this particular state. Now it is waiting for the next sequence number, which is segment number 0. So that is how reliable data transfer 2.1 version works, and it has removed that ambiguity that receiver should receive that redundant or retransmitted packet or not with the help of sequence numbers. Thank you very much. In the next lecture, we will discuss about RDT, uh, reliable data transfer, next version. Thank you very much.